Hello everyone. After a short break, sorry I haven't uploaded the videos. It's because I've been quite busy actually, the New Year's and a lot of projects going on with my work. But more on that later, that's not important. So, yeah, welcome back after this period. I hope you've learned something in the meantime. If not, well, you're surely gonna learn something cool today. So today's topic is going to be about modeling and data structures. One of the topics that I would consider pretty a weak link in a knowledge of average front-end developer. It's pretty common actually to follow design patterns and data structures and algorithms and modeling per se in other programming languages, especially on the backend. I'm really stunned to see that it's not very common and knowledge in the front-end world. I don't know why, because these days front-end really looks a lot like back-end. So it's pretty funny to see that actually people who apply for a job at Kobiro, they lack that knowledge, Like I'm gonna show you a couple of anti-patterns that I see. I'm gonna show you some of the basics, and then we're gonna move to more advanced stuff. So you're gonna see an examples of like what commonly people do when I don't know designing tree structure. But then as soon as we get to like interview part and I ask them why did they do it like this, I can clearly see like they don't know. They just Google the solution online. So don't do that. Bear with me. It's probably going to be a little bit different than what you're used to. Just please have an open mind and try to look at it from different angle. And I'm really going to give you some knowledge that's going to extend your toolbox as a developer. So bear with me and let's get to it. So the example I'm going to show you right now has nothing to do with the actual application we are building. I just want to give you a bit of a theory. So let's imagine I want to create a product. So I'm just going to navigate somewhere, probably in somewhere like infrastructure folder where I'm going to build my domain models. I'm going to have a product here. Okay, so let's imagine I have a product. So what normally people would do? They would go ahead and create a product interface. Then they're going to have a name and a price. So that's like the simplest product you can think of. So probably it will have some sort of ID, right? Okay, let it have an ID. So that's something you fetch from the backend. You just think about it like, hey, that comes from the backend. Let me just model it in the interface. But this is very controversial actually. So a lot of people think that interface equals modeling, and I totally don't agree with that. So interface is not a model. Funny thing is that it actually works like a model in TypeScript, but if you look at the interface in any other programming language, it's not really. An interface, like the name suggests, tells me what is inside of an object, right? So there is the solid principles, and one of them is like interface segregation, and it says that you should not have interfaces passed on around as data transfer objects and then just pass more data to the clients than it's actually needed. So you should design your interfaces to be small. So that interface could easily be three interfaces called has ID, has name, and has price. Like look at even Angular, right? So when you go to the Angular component, the live hooks, right? So you can easily have implements ng on init, implements do check, after view init, whatever. So you see, these are single methods that allow your component to implement, and once you do, the framework or platform of Angular will know to call those methods in a specific moment of the life cycle of the application. So that's what interfaces are designed for. They are not designed to make a models out of it. Actually, funny thing is that it's really handy and it's easy way to do it. So people often ask me, yeah, but you never use interfaces like this? And that wouldn't be true. I actually do. I do it exactly the same way as it's described here and as you probably do. It's just that I do it for like simplest stuff to start off. As soon as I need to put some business logic, or as soon as I need to differentiate a little bit differently and start model my domain in more sophisticated way, as soon as it's not just a CRUD of pushing things from left to right, from UI to the service, as soon as I start having some states, I don't use interfaces like that. I just start using classes instead. And here comes an argument I hear all the time. Creating classes makes your bundle bigger. That's the argument I hear for using interfaces. And probably true, but you could argue with that though. So let me argue with it a little bit. So a first reason why I don't think, so people who say that, I think they are penny wise, pound foolish. It's an expression in English which means you focus on like a small part of the optimization and you lose the whole big picture behind it. So what do I mean? I mean, yeah, how much more kilobytes, not even kilobytes, how much more bytes is that in the actual bundle? Well, it turns out it's not much. I'm going to show you an example later. But like interface does not come in a bundle because it's just runtime only and it's not part of like the bundle of Angular. And generally TypeScript, just ignores them later. But the thing is, class is not, right? Yeah, but like writing a class with 3 properties, is that a lot? That's not a lot. That's a couple of bytes. I mean, yeah, it gets translated to a function with the prototype by TypeScript, but that's not a lot. But think about all those benefits you have using classes. It's enormous. I mean, you can have a logic that will check your price after you set it, or you can transform it by having some nicer getters. You can, you have immutability, right? I mean, no one stops me from setting the ID on the product. And then you have a reference problem, right? Like the top level layers can push that object down, and then you can change it somewhere in your UI by accident, and it's changing all your application, right? Okay, sure, you can spread that object, but still, nothing stops you from changing the ID along the way, and I consider that a very bad practice, right? But if I have a class, I can use public read only. I know TypeScript starts to ignore it, but at least when I code it, it prevents me from doing so. And then you can use privates, and you start having you can use only getters, right, on top of it, and then not have a setter and private properties. So that's another way of going about it. So the whole immutability is very important, and especially in JavaScript, because everything is getting passed by reference. I'm going to show you an example later, but trust me, it's a big win for your application and helps you model things a lot better and protect, the price doesn't necessarily need to be number. I mean, it could be like an object containing a value and the currency, stuff like this. So think about modeling helps you read your code, and remember, those couple of bytes make no difference in the end. But what really makes a difference is that the next developer will come in and be able to be productive from day one. You can argue with that though. If you've never done the classes, you're not going to be more productive. You're actually going to feel weird to start with. And I understand that. But please join me in the movement of modeling better in TypeScript and Angular in general, because it's really worth it. I mean, if you design a simple CRUD application, fine, go ahead with interfaces. That's actually what I advocate too. But if you create domain-rich interfaces, you might have tons of drag and drop, you might have tons of interfaces talking between each other, you might have business rules in those models, you might have a rule that, I don't know, price cannot be negative, right? Where would you put that logic? Price cannot be negative. You can have it in a validator and stuff, but then you start having a code smell of feature envy. I'm gonna show you that maybe if I have a bit of time. If not, leave me a comment and I'm gonna upload more videos about it. But anyway, leave me a comment and tell me what do you think about that approach, like interfaces versus classes. And I'm ready for the hate. I'm ready for it. But I think if you're open-minded, at least if some percent of you will actually change that approach, I think I won my battle. So thank you, and let me show you an example how you could actually do it using classes instead. Okay, so let's start with design first. So what we're gonna do is start pretty much the same, except that instead of interface, we're gonna use a class. There we're gonna have a constructor. So let's wait for a second. What does that tell me? Well, that tells me I can set that. So it creates a property in that class called ID. It's public property, but I cannot set it from the outside. I can set it inside the constructor. So I can still modify it inside, but I cannot set it outside. I cannot even set it after in another method that can be called from the outside. So it's read-only. I really like the read-only actually. It helps me a lot. It helps me keep my immutability problem saved. And it helps me with even if I would like to save that object somewhere, like in local storage. With private methods, things get a little bit worse because you would have to call the new operator all the time. But in this case, it's pretty straightforward because what you can do is just, it deserializes it immediately. A bit of a geeky knowledge, but generally it's cool. It's good to start like this. I really recommend that way. Then the next thing is the validation, right? So where would you put the validation? Well, one place is to put it here. You see, you probably haven't seen that a lot, but you should. Like, some people might say, like, why would I throw an error? Well, you want to throw an error because you want to approach it from like defensive programming approach, where you want to protect your classes from the values that are like clearly not gonna work for you. Like, there is this like very old trick of how would you actually add money to your bank account? You would put a price, which is the negative, and deduct it. So that way you will actually add things to your bank account. So this is like very old. Obviously there are like tons of checks already done in the frameworks in the backend for you, so it wouldn't be possible. But wouldn't it be nice if at least I would get an error? Sometimes, you get those bugs, right? You create this like pretty big application and then errors start throwing at you left and right, and it could be like by accident. So that checks will tell me that exactly in this line something went wrong. And it's pretty powerful actually. So that's pretty cool. So this way I have immutability and I have a validation and I have all that encapsulated in that class. That would not be possible using the interface. So that's one thing. And how many more bytes of code will that be? Not many really. It's just a couple of lines and a couple of symbols. It's not a lot. I mean, it's not like for every new I'm gonna add that object to my bundle. I just add it once, right? So trust me, I tested it. It's not a big difference. So let's add one more case in which you would think that, this class is a lot more in a bundle. So let's look at this. So originally we had the product interface. I just added interface so it doesn't collide with this name. It's exactly the same as here. And then you need to map that function somewhere, right? So let's say you have something from the backend coming in and the backend response contains a lot of information, and then you want to map that into that interface. So you need to map, let's imagine this is a function used inside of the service class, and then you map it, and then tell me, that's bytes too, right? I mean, you do that, it's bytes. Quite often, people would not even create a function. They would actually just, do the mapping on the fly. And as soon as you do it in more than one place, you create a lot more bytes than this. So again, don't be penny-wise, pound-foolish about that. I mean, you lose the value of immutability, and you use the value of the validation, and you use one more important value. Let's say a price is the number, but what I expect in my UI is to have a price with the dollars. So let's say I just support only one currency called dollars. So I can have a get price. So in that case, this one, I would like to make a private. And I cannot use the same name, so I'm just gonna use the underscore convention. You don't need to do that, but I kind of like it. And then what I can say, I need to return a string. And then what I can do is to use the template thing. Look at that, I can model it here. And yeah, I could do it in a map function too. Sure, but I prefer to have all my logic in one class, you know. Maybe next time I'm gonna get a price that another type of product, another type of response, and then, you know, I will have to go to all my mapping functions and change it there. But maybe sometimes, you know, I would like to add a method called can be discount. Can have a discount. I don't know. That will return a boolean, and it will tell me that it can have a discount if the price is bigger than $10, right? So if I model it here, I cannot really do it because I lost the information. I would have to remove the dollar and the string format of it, and then have it here. And yeah, I mean, sure, you can use pipes and stuff like this. This is not the question about alternatives here. This is like, I like to have all my domain logic in one place. So let's say I have a business rule says, yeah, hey, I can discount this product as long as it's more expensive than $10. Now here I would have to put maybe original price and the dollar price, and what if I want to change dollars and to, I don't know, pounds or whatever, you know, then I have to have a pounds price. You know, this thing gets very easily complicated. So in this approach, I hope you can see all the benefits, and, you know, the whole power not only of immutability and formatting and validation. I can, like, this is like the basic object-oriented programming principle. Like, I just like to have all my logic in one class, right? So let's say, you know, I want to explain the business rules to the next programmer that comes into our team. I don't jump in between 20 different files, and this whole thing gets overly complicated. I just can show him this one class and show him the rules are like this, right? So this is like a classical product example. Of course, there could be even more modeling principles. Like, actually, I believe the price should be a class in itself as well that will contain all this logic and all the validation inside of it. That's what I would normally do, but I wanted to keep it simple just to introduce you, because remember, this is just a theory, but let's get to some more examples of actual application. Okay, so this is an example from the application that we've been building in the previous mini-series. So here I have something called item, which represents a list item, right? But actually, does it really represent an item? Let's think about it. Like, one of the very important things in modeling is how you name things. Item doesn't tell me much. Like, when I think of, what does come to your mind when you think about the items? Well, I think about list items, maybe, like purely presentational. Or it definitely, like, an item is part of the bigger collection, because then you have a list or collection and then it has items, right? So I know it's like iterable. I know it's like part of like iterations of like loops and stuff like this. But okay, let's look at what this item contains. So we know this item should be shown in a list which is represented as a tree. We covered that in a previous video. So what do we know? Well, we know it has an ID, it has a title, it has an optional parent ID, and it has children. So this is a typical way of how people design trees. And I think it's a terrible way, to be honest. So let's talk about some of the things here. So children, that's cool. I really like children. I mean, you can see the recurrency here. I can see a children, an item. Well, children will be the item. So it's a recursion here, right? So item can contain more items. That's cool, that's fine. But then why do I need a parent ID? And why the parent ID is a question mark? I mean, I understand it means it's optional, but why would I have interface with optional parameters? Like, it's usually a code smell. So what is a code smell? A code smell means it's a part of a code that smells, yeah, but it's a part of a code that it's not necessarily an anti-pattern, but it probably is. I mean, if you have to dig deeper and understand the meaning behind it, but it quite often means there might be an anti-pattern hiding in there. But it might as well not be if there is like a super senior or expert developer doing that and then he knows what he's doing, or maybe it's like a temporary thing, that's fine. But like if this is like a production done code, yeah, I would be skeptical about it. Because why do you create optional things in the items? In the interfaces? I don't think you should do that. You know why? Because the next thing you know, you're gonna have 20 different parameters, and it means your modeling skills are not very high. Because technically, you could design this as two interfaces, right? Or you could design it as, you could have interfaces in the middle. Like you actually don't model. You just have a bag of properties that you throw things at. That's not modeling. That's chaos. Think about it. Like what's the best way to do it? So we know this interface is something that comes from the backend, right? Yes, we do, because there is a service. If I can find it, let's see where it's used. All right, I have a usages of my class here. So first of all, it's used in the data service. It's used in the infrastructure. Makes sense. Data service is part of the infrastructure. So I have actually I copied it from this class, so don't mind it. So it's part of my infrastructure, but it's also part of my UI. That would be okay if this is used as a DTO of transferring the data in between the infrastructure and items and UI, but I don't think it is. So let's have a look. Yeah, right. I mean, it's used as the property, and it's used, check it out. So it's used in these two classes. Here and here. Okay, so check it out. My item service fetched that from the backend, and my UI service is using the same interface to display that inside my templates. So it's being fetched here to my CDK tree. That's an anti-pattern. It's because it's the same interface, it's used in both places, and it has a question mark. So what you should do instead is to have two interfaces. Yeah, you should have two of them. One that represents the backend and one that represents the UI. I mean, again, one that represents an infrastructure interface, that's one interface. Another interface could be like the domain logic, but this example is super simple. It doesn't have any domain logic yet, so don't mind it. And then the next one is the one used in the UI. So let me go to the UI, and I clearly see it's CDK tree, and it even like calls it a node. So a proper name of one of those interfaces would be node, because that's what it is. And then the second one, items, called from the backend, I just leave it as this. It's okay. I mean, I don't know much about this backend, so yeah, maybe item is okay. I mean, I don't have a better idea, but definitely you need to make two interfaces. So let me show you how can you do it. Okay, so let's design the node thing. The node model, so I start with the test as always. So I'm gonna make a node, maybe, all right. And then in the I'm gonna just create it, so I can just do one liner here and do the expect tree node to equal. So the tree node will contain different parameters. One will be the number of ID, so it needs to have some sort of ID, and then it needs to have some sort of a data being injected into it, and then the children. For now, I skip the children. To equal just mean object containing and exactly the data here. So after I call the new on the tree node, I want to have an object that will have an ID of 1, data of empty object, and children of empty of an empty array. and maybe I want to call the whole test a tree node. So if I run that test, obviously that's not gonna work. Yeah, I mean it doesn't even have a, this means test doesn't work. So I'm gonna go ahead and make the implementation. So I need to make the tree node that will contain the specific constructor. So let's test that. And sure enough, we're passing. Okay, so this is an ID, the data, and the children of the default array to start with. So the thing that really bothers me now is the any. So what should that data be? I mean, I can just make it an item, right? So cool. Now I can. It's pretty cool. It's much better than just having an item in here. But it's also not optimal because that tree node should really represent a node in the tree. Whether it's a root node, a leaf node, a part of the branch, it doesn't really matter. So what matters is it has an ID and the children. That's the only thing I really care about. And then it has the data and whatever data is in there. So what I can do here is to show off my skills of modeling and start introducing a generic type. That's pretty powerful, isn't it? Because look at it. Tree node doesn't care what's the data. It can be whatever data. Now it's reusable. So try to always show off in your Angular interview skills that you know about the generics in TypeScript, because that way, you look much better on the interview because you think about reusability up front. So check it out. If I rerun that test, I should still be passing. That's fine. That's totally fine. This is the old thing. Okay, so and now since the children are part of the node, we don't need that one here, and then we clearly don't need this one to be optional, and that should still work. Obviously now my item will be only used in my infrastructure, so when I navigate to my infrastructure service, that's still going to be the same because this represents a contract. So this is why I don't want to change it from the interface, because I like to use interfaces in between the layers and in between my application and the outside world. That's totally fine because I don't really model anything. It's just a contract. So that's fine. But then inside of, I should probably use something different. So here comes the question, should that get items return an item? Well, yes and no. No, if this is meant to return a domain model or some sort of presentation already data structure, it's really up to you. Yes, it's super simple. We should keep services super simple and then do the data binding somewhere else. So it's up to you. I actually like to return already model data from my services, but that requires a new pipe in here. You can also do it in a smart component, so it's really up to you. Let's have a look how it's actually being done by the candidate. So here we call the items and then we model the data in this function. So what does this do is data array to tree. So obviously the items here should be of type node. Tree node. That's cool. Of type. Well, I can define my own type here. I can call it. Well, I can use item for now. And then later I can change it if I would like to. But it would be nice to have another interface that will have only title and the ID. Okay, so I have my tree node, and then that doesn't work. Because the data to tree doesn't return a tree node. So let's look at this function. So I love the to do to refactor in one of my previous videos. If you look at this one, this is actually most common implementation of the same thing. There are a couple of skeletons in the closet, as I would call it. I'm going to talk about each one of them just now. For now, I wanted to tell you that whenever someone shows me a solution like this, and I ask them more in depth what is actually happening, they cannot really explain it. I mean, we can start building the test cases around it, and they can't really help but just say they Google the solution. And actually, when you Google the solution, how to turn an array to tree, In JavaScript, you will get exactly the Medium post showing you this piece of code. So I can clearly tell the guys actually did it. So let's talk about the anti-patterns in here, and then how can we do it better. Okay, we don't have a return type, so typing is off. The second thing, we're just using like objects and spreading things around, and clearly here, this is why we use the item interface, so it's easy to just like, spread around and just don't worry about things. The second thing is like using for loops. I particularly don't like for loops, to be honest. Like maybe it's just my preference. Call me new fashion because this is super old fashioned. I mean, I haven't seen for loops in more than JavaScript. It's because you have like map operators, you have radius, you have filters, and you should think about it like declarative code. And this is like super imperative. It really reminds me of like C++ and stuff. Sorry, like no hate for C++. I think they are great programmers, but generally it's super old school, right? I mean, like it doesn't read as well, and like I like while loops though because they can help me make things with sophisticated algorithms, of course. But for loops, I don't quite like this. I mean, and he's also like sort of mixing. There is a for off, and then there is this for with let I and so on. It's like I'm not sure if the guy knew what he's doing, like it shows me inconsistency in his code and solution, and there's an if statement in the middle. Like, why would you do it? I mean, you have reducers for this. Or, you could use map and filter. That would be very handy. But yeah, I mean, those things I particularly don't like. You could argue that, hey, I just like to do it this way, and that's fine. But I mean, why wouldn't? Then I ask you to use the map operator or use reduce, and this is why people actually fail quite often. And then there is this one interesting part, exactly this one. This one line of code changes everything. So if I ask people what happens here, they cannot really explain. So let me explain what happens here, because normally if you build a tree in any other programming language, the most naive and the simple solution would be to use recursive function. So that function would call itself a couple of times. So you might be thinking like, why this works? Because actually it's very clever. If you think about it, like what's the complexity of this algorithm of building the tree? So well, okay, here is one go. I just go to model it. That could be reduced, I believe. But okay, let's keep this one for now. Let's focus on the actual algorithm. So here is on, because I go through whole array of list, which is really an item of data that gets passed one time. And then I go for this one more time, so it's O to N, so N times 2, really. So all I have to do is to go through this array 2 times. And then the recursive, I believe it would be O(n) squared. Please let me know in the comments if I'm mistaken. But it's definitely much more complex. It takes a lot longer time to run. I mean, not like that is a big problem, because in front-end you don't load tons of data. I believe maintainability is more important, and readability of a code is more important than just squeezing out to logarithmic n or something like this. We're not really this data could be paginated already. Like a lot of the stuff is like valid in the backend, in the front end not so much. Like the machines are pretty powerful these days. Well, it's not so good on the mobile though, but if you're not designing application for the mobile, then I wouldn't worry about it so much. But okay, let's have a look how to do it better, how to make it work a lot nicer, and I will explain you the bit that is the magic here. So the magic, O2 and complexity here is, what you need to do, you have a data item that contains the parent ID, right? Then you just model it to append the children. So now is the part where the parent is optional and then the children. So you spread that items in here, and then you model a node. So this is like a node list really, or node array. So you append the children. So now the item becomes a node, and then you go and build something called a map. You could argue to actually have a map in here, but like a data structure from TypeScript, or I think JavaScript too. So, but generally think about it like this. I want to go for each node and create a separate array, or, well, sorry, it's an object actually, a dictionary or a map. So generally it's a key value pair. So what I want to do is to create a key value pair data structure that in the key will contain an ID of the item, and in a value it will contain an index on which I can find that item in the array. Okay, so bear with me. A key will be the ID of that item, and the value will be the index on which I can find it. You will see why. Then we go, and don't mind that part, and then we go for this item one more time. For this list, I go one more time, and what happens is I say if this item has a parent ID, which means it is not a root node, because the parent ID null or undefined or whatever you want to do is going to tell me it's actually a root node because it does not have any parent. A root node is the top of the tree, right? So if it is not a root node, then go and find that item. How? Well, I go to the list, and then I say find me in the map I've just built a second ago, and find me all the nodes which IDs equals to this item that I iterate over, parent ID. So here I build all kinds of lists. So I can say, okay, so this is like ID 1, 2, 3, 4, 5, whatever. And then find me in this array all the people that to me are parents, and then append them to my children, right? So I find the item to which I am children to, or I find items who are my parents, and then I append myself to its children. And it works because JavaScript works by reference. So this magic piece of code allows me to pass objects by reference. This video is not really about the reference of value passing, but JavaScript works like this, and this is the magic bit. It actually finds reference of a lot of other objects as well and just appends it. So it's really magic, to be honest. But hey, you know, programming language allows me to do it. Why not to use it? Especially that it makes my code a lot faster, and it also, I believe, it's quite readable. I mean, if you know JavaScript, it's really readable to you. If you don't know JavaScript, yeah, that's gonna be less readable than the recursion. But generally, this piece of code does it. And then I can say, okay, this is for the item that is not a root node. What if I am a root node? Well, then append me to the roots. So just an array that I want to return eventually. I hope that's clear. Let me know if it's not, and I will delve into that later. This will be the tree builder. So tree builder will be just a function that allows me to build map really items into the nodes. So here we go, let's start with the test. And then in the test, I'm going to have a data of items, which will have ID, title, and parent ID null, so it's only one node. Then I will have what I want to really get out of it is I want to have the same ID. Data will be mapped just to the string. It's because in my UI, I don't need anything more than just the title. I certainly don't need the parent ID. And I don't need I need the ID, but that's already mapped into the ID of my node. I just map it one-to-one, and then it should not contain any children. So let's have a look. I'm gonna have this function of build tree that is gonna take the data, and then turn that into a tree of expected. So then I want to check that the actual length of that built tree is 1, and if it's 1, I want to have that, you know, the first element and the only element will be of value of the expected outcome. So notice that I call Jasmine object containing here is because very likely inside the build tree I'm going to be using the model I've created a second ago, that one. So I want to keep it you know, independent from the type of the object, and not to worry about that it has a different reference, because, you know, if I call new here and new inside the build tree, the equal will not actually work. So this is a neat trick to help you make your test less brittle and focus on actual values of objects instead of you know, what object was created. So, okay, when I run this one, it's not going to work. Yeah, I'm going to have a compiler. Yeah, don't be fooled by this. I mean, let's have a look. It must be some sort of a karma issue. But it can't work because this function doesn't exist. And then let me build that function. So a build function will take array of items, and then it will return an array of 3 nodes of type string in the data. So I'm going to iterate over the data in the item list, and then I'm going to create a node for each one of them, and then I omit the parameter for the node because I know it's a root node. So this is sort of like lazy me doing here. And after I run that test, here we go, karma. Yeah, I'm passing, and it's totally fine. All right. One more thing I had to do in the items controller, I had to distinguish. So the items come from the get items is an item array, and then I use the build tree, not the meta, not this function that I just explained in the previous couple of minutes, and then I typed it here, so you know that if I iterate over nodes, I call this .children, so pretty much the same. And then that tree node is view ready data. So in my components as well, I just called node.data on it because that contains the title of the string. So that's the only difference. Okay, let's get some more sophisticated test cases. Okay, so let's modify data slightly. And the way it's gonna work is now I'm gonna have 2 items, which the second will be a child of the first item. And then what I really expect is that, you know, there will be still 1 root node, and then its children will be the object that contains the data from the second item in the array. When I run this one, it will fail. It's because now he thinks there are 2 root nodes, so this test case fails. It's because here I just map things. So that's not good enough because I don't have a depth. I just map things. If I have 20 items, it's going to be 20. So let's look what we can do. Alright, didn't work out very well. Okay, so what we really want to do is to follow the previous algorithm. So I'm going to show you the O3N where I actually map it to the tree node, and then, yeah, there is a O2N approach, but I would like you to actually tell me what is it. But let's start with the basics and a very simple algorithm. Okay, so we really want to build this item map. This item map will contain a map between an item, its position in the array. So for the item ID, we want to see what is his index in the original array. The next thing is I want to map those items into the nodes. So this will make sure that we have a children property. Which is the empty array. And it's funny enough because we map over the same array as the data. The indexes here will pretty much be equivalent of this item array and the original item array, if that makes any sense to you. Then what we want to do is we want to reduce, so we want to go over each element in the data. Then we want to extract a node. So notice what we do here. So for the nodes that are being mapped, we want to take, for the item ID we iterate over, so it's 1, 2, 3, 4, whatever it is. We want to map it to the node. So this is the reference situation. This is the magic. So what we do is we say, okay, I go for the first item. I want to find it in the map, so I want to get the index of it in the nodes array. Okay, and because I iterate over the same, so it's the same index. So here I'm going to get the node from this based on the ID. That's pretty much all it is. It says, based on the item ID, get me the node that references it. Then we want to have two cases. Am I a root node? Am I not root node? So let's start with the I am a root node. So if I'm a root node, just add me in to the roots. A root is just an empty array on the reducer. All right. If I'm not a root node, then find my parent. It's exactly the same paradigm. So go to the map, find, based on the parent ID, find the node that represents my parent. And it must be here because I mapped all the nodes. Then append to my parents' children, append me. So just append me to my parents' children, and then return the nodes, the roots. Yeah. So after this works, I can run the test, and sure enough, it works. I know it's quite complex, but I hope it makes sense actually. So I can assure you that now you can add any more cases and it will work, because it's pretty much, it should work. So feel free to hit pause and go back a little bit in the video and replay that if you didn't understand it. But the whole magic happens when we actually can reference things by the item, either item ID or item parent ID. And then we reference the nodes that we previously create with the empty stuff. So what happens is, again, one more time, these nodes originally contains, each of them has a children that are just empty array. But if we get the reference of it in this line, this nodes array will get modified. I know you don't set it. I know it's not visible from the start, but it is actually. This line of code, when you inspect these nodes after each iteration, you will see that nodes inside with empty children starts getting another 3 nodes inside of it. And then we can push it anytime. And it doesn't matter if we push the parent before we alter its children. It's because we both reference from here. We both reference the nodes array. This line will modify that array, and therefore that array, when it's modified, it will also affect the roots. It's a pretty funny concept, but it works. Okay, let's go to the refactor, because that looks like a mumbo jumbo everywhere. So let's get more object oriented here and get some proper modeling. Okay, so what we can, I think this part of code is not very object oriented. I mean, check it out. Like, I get the parent, and then I need to get the children, and then, you know, oh, make sure there are children that you append to it. I mean, you know, like, why does the build tree needs to know all this logic? What if I want to change representation of this not to be array? Maybe I want to have it as a map, you know, maybe I want to have it as a set or whatever. I mean, this part of code will have to be altered, and that's not object oriented. So let's modify it. So what we can do is to go to the node spec file, and then when we had this one, let's add the new test, and then say, okay, it should add a child. So what we can do is that we're going to get the parent, which is just a node, and then we're going to have a method add child, which will add another node with another ID, and then we want to check that the parent, the children at 0, because it's only one child added, its ID equals 2, exactly this one. Obviously, if I run this test, it's not going to work. So let's go ahead and build that function. So here are children, which is of exact same type as the current node. Then we want to just say we can do like this, we can do children.push, we can do the spread operator like we did before, but I think that's going to work as well. Okay, before it used to have a problem, and now when I run it again, it's all fine. That's cool. Okay, so going ahead, we should go back into our tree builder and change that. So here we can do add child of a node. That's much better. Actually, going with it, what we can do, we could even totally disregard this whole variable. It's up to you. Like this, I would consider a lot less readable than the other one. But well, I don't know. Maybe you like less code, less lines of code. It's up to you. I mean, I know what I'm doing. If you don't like it like this, just keep it as it was before. All right. So what else can we optimize? Then I look at the tree node. We never really give the children here. Like it's the only place where we actually call it, and doesn't seem to give any value. So what we could do is, you see, this is a public. I had to remove the read only because of this adding the child part. Now it cannot be read only because I altered it here. So I could use this neat trick I've been showing you before. I can remove it from here altogether. Sorry for the sound. Make it private with the children, which is always an empty array. And then I could use the private method here, and obviously now I can use the getter. The tree node of t and return that. So this is a neat trick where I can keep my immutability, sort of. I mean, like a direct immutability. What is happening? Oh yeah, it's an array of tree nodes. Okay. Now I can sort of keep my immutability. Yeah, okay, this is my linter like going crazy. He doesn't like these things, but I like it, so I will ignore it for now. So that's another way. It's a little bit better. I think this class is pretty cool for now. Is there anything else we can optimize? Okay, Refactor, that's pretty cool. I mean, there are a couple of things I could do. Like, I don't like to have that logic in here. But as you remember, item is an interface. So here we go, you know. I decided to keep it as interface only. But if I had like a class implementing that, I could have like a method called isParent. Because what if backend comes in and says, hey, you know, it's no longer null. We have to make it 0 or -1 or whatever silly number. And then that logic will change here. So I hope you see like passing interfaces is very shallow way of modeling. It is a modeling, but very shallow. So, you know, I can't wait. Let me show you a even better way. Like, so I told you this complexity here is O3 because it's one time I go over the array, then I go again just to model it, and then I go for the third time. So it's O3n. Can we make it O2n? Well, of course, and there's like very simple thing actually to do it. If you don't see it, don't worry, because it's not easy to see from the get-go, but check it out. So why do we use this index? We use this index so we can like create an array of tree nodes and then reference that in this array. But you don't need to do it. You can like disregard the whole index part. What you can do is to model it already here as a tree array. Look at what I'm doing. My item map is not going to be now storing indexes. It will store a reference of the object that I want to return. And then in here, I can remove this whole node. So now it's an object containing where the key is the ID of item and the value is the actual node I want to use. And all I can do is to remove this. Check it out. I can just use it like this. And let me show you the tests. They should be passing. I mean, I can see in the UI it works. Yeah, check it out. It's 2 successes. And yeah, I mean, test it out. Just add as many cases as you want. I can see in the UI, which has a lot more complex data structure, it works. So check it out. It's O2 n complexity. What we could be doing here is to be adding more things, more typing. Sorry, it's a string array. And then this one is an item. Check it out. We're good. I mean, the last thing could be like maybe reducing that if somehow. That's not very clear. And this array we could maybe turn into 3 node as well, but then we would have to have like a special deroot node approach. But that's pretty much it, guys. I mean, I hope you learned something today. I'm trying to look if there is any more optimization, but it sounded cool. I hope you now understand the power of classes and modeling, that there is a lot of benefits. It helps you with the code being centered in one place, and so you support open growth principle, where it's open for extension but closed for modification, and when some interface change happen, it doesn't affect your classes, it only affects the layer where it actually lays. So you don't have that coupling problem and spaghetti code where you can changes in one place affects the other one. You keep the loose coupling and high cohesive system. So it's pretty powerful. It's really awesome. I hope you learned something. I know it's controversial, but just give it a go. You never know. I have had a lot of developers coming in to Kobira, and they went through the same process, and once they learned that concept, they were like, wow. I never had a guy who would come back. I only had the guys who said, okay, in this very simple case, I want to use the interface. But in most other ones, I was like, the benefit is just too huge, to ignore it. So yeah, thank you for that. Leave me a comment. You may subscribe, you may not, do whatever you want. But it's nice to hear, a bit of a comment of whether positive or negative feedback. I'm looking forward to it. So thank you for that. Thank you for today. And I think that concludes this series. Maybe I'm gonna make one more small video about how to connect reactive streams, because there is a nice opportunity. But for now, that would be it. Thank you. Have a nice day.